What if everything you believe about death is wrong? Not spiritually wrong, not philosophically wrong, scientifically wrong. What if the moment your heart stops, your brain doesn't shut down, it wakes up? What if the last thing your mind does before it goes silent forever is produce the most intense experience of your entire life? That's not a theory, that's what the data shows, and it changes everything. For most of human history, death was simple. Your heart stops, your brain goes dark, you cease to exist. That was the assumption. That was what medicine taught. That was what science accepted without question. But in the last 2 decades, a small group of researchers decided to actually look. And what they found has divided the scientific community, disturbed neurologists, and left some of the most respected doctors in the world without an explanation. In 2013, a neuroscientist named Jimo Borjigin at the University of Michigan published a study that nobody expected. She and her team had placed electrodes on rats and monitored their brain activity during induced cardiac arrest. The moment the heart stopped and blood flow ceased, they expected to see the brain go quiet. Instead, they saw the opposite. Within seconds of cardiac arrest, the rats' brains exploded with activity. Gamma waves, the fastest, highest frequency brain waves ever recorded, the ones associated with the highest states of conscious awareness, surged to levels that exceeded anything measured during normal waking life. The dying brain was not shutting down, it was firing. The study was published in the Proceedings of the National Academy of Sciences, one of the most prestigious scientific journals in the world. Borjigin described what they observed as a surge of neurophysiological coherence. In plain language, that means the dying brain was not falling apart. It was organizing itself, coordinating itself, becoming, in measurable electrical terms, more conscious than it had ever been while the animal was alive. Nobody had an explanation. The study was real, the data was real, and the question it raised was one that science was not prepared to answer. But that was animals. The obvious question was whether the same thing happens in humans. For years, that question had no answer. Then, in 2023, Borjigin and her team did it again, this time with people. They identified 4 patients who had died in the neurological intensive care unit at the University of Michigan while connected to EEG monitors. All 4 were comatose and unresponsive. All 4 were beyond medical help. With their families' permission, they were removed from life support, and the team watched what happened to their brains. In 2 of the 4 patients, the same thing that happened in the rats happened in the humans. The moment oxygen began to leave the brain, gamma wave activity surged. The activity was not random. It was concentrated in a specific region called the temporoparieto-occipital junction, the area at the back of the brain where the temporal, parietal, and occipital lobes meet. This region is not random either. It is the area that neuroscientists have identified as the hot zone for conscious experience. It's the area that activates during dreaming, during visual hallucinations, during altered states of consciousness. The dying brain, in its final moments, was lighting up exactly where you would expect consciousness to be. George Mashour, the founding director of the Michigan Center for Consciousness Science and one of the co-authors on the study, described what they found in these words: how vivid experience can emerge from a dysfunctional brain during the process of dying is a neuroscientific paradox. That is not a quote from a spiritual leader or a philosopher. That is a neuroscientist at one of the world's leading research universities using the word paradox to describe what his own data showed. The brain should not be doing this, and yet it is. Now here is where it gets harder to dismiss, because the question this research raises isn't just about brain waves. It's about what those brain waves mean. And to answer that, you have to look at a different body of research, one that had been building for decades before anyone put electrodes on a dying brain. In 1988, a Dutch cardiologist named Pim van Lommel began noticing something he couldn't explain. His patients who survived cardiac arrest kept telling him things, not vague things, specific things. They described floating above their own bodies, watching the resuscitation from above, reporting conversations that happened in the room while they were clinically dead. He was a scientist. He was skeptical. And precisely because he was skeptical, he decided to study it properly. For 13 years, Van Lommel tracked 344 patients across 10 hospitals in the Netherlands who had survived cardiac arrest. He interviewed them systematically. He controlled for medications, psychological background, prior beliefs, and medical conditions. In 2001, he published the results in The Lancet, one of the oldest and most respected medical journals in the world. 18% of the patients reported a near-death experience during the period when they had no heartbeat and no measurable brain activity. Not a feeling of drifting off, not a dream. A structured, coherent, lucid experience that survivors consistently described as more real than ordinary reality. What Van Lommel found that disturbed him most was not the percentage. It was the consistency. Across patients who had no contact with each other, across different hospitals, different backgrounds, different levels of religious belief, the core elements of the experience repeated. The sense of leaving the body, the perception of light, the encounter with deceased relatives, and in some cases, something harder to explain, accurate perceptions of physical events that happened in the room while the patient had no heartbeat and no brain function capable of producing conscious experience. According to established neuroscience, those perceptions should have been impossible. Meanwhile, on the other side of the Atlantic, a doctor named Sam Parnia was asking the same question in a different way. Parnia, a critical care physician and resuscitation researcher, designed what became the largest scientific study of consciousness during cardiac arrest ever conducted. It was called the AWARE study, Awareness During Resuscitation. Over 4 years, across 15 hospitals in the United States and Europe, his team tracked 2,060 cardiac arrest cases. Of the 140 patients who survived and could be interviewed, 9 reported a near-death experience. Of those 9, 1 case stood out. A patient reported a detailed out-of-body experience during cardiac arrest, watching the resuscitation from above, describing specific actions taken by the medical team, describing the sounds and movements in the room. Parnia's team verified the account against the medical records. The description matched. The patient had accurately described events that occurred during a 3-minute window when there was no heartbeat. This is significant, Parnia said, since it has often been assumed that experiences in relation to death are likely hallucinations or illusions, occurring either before the heart stops or after it has been restarted, but not an experience corresponding with real events when the heart isn't beating. One verified case is not proof of anything. Parnia was careful to say that, but it was also impossible to dismiss, because a hallucination, by definition, is not accurate. A hallucination does not correctly describe what is happening in a room you cannot see, in a body you are no longer conscious in, during 3 minutes when your brain should be producing nothing at all. So where does this leave us? Here is what the science actually shows. The dying brain does not go quiet. In at least some people, it surges with electrical activity concentrated in exactly the region associated with conscious experience. That surge happens after the heart stops, after blood flow to the brain has ceased, after the biological conditions for consciousness have supposedly ended. At the same time, a significant percentage of people who survive cardiac arrest report coherent, structured, lucid experiences during the period of clinical death. Experiences they consistently describe as more real than anything they have ever felt while alive. And in at least one documented, verified case, those experiences included accurate perceptions of real events in the physical world. None of this proves what happens after death. The researchers themselves are careful about that. The 2023 Michigan study had only 4 patients. The AWARE study had 1 verified case out of 2,000. Van Lomel's critics point out that the brain may produce these experiences in the seconds before death or the seconds after resuscitation, rather than during the flatline period itself. These are legitimate scientific objections. They have not been answered yet. But here is what has also not been answered. Why does the brain surge with consciousness level activity at the exact moment it should be shutting down? Why do people across different cultures, different religions, different countries, and different centuries describe the same structured experience at the threshold of death? Why does one cardiac arrest patient accurately describe a room he could not see during 3 minutes his brain was not beating? Science does not have answers to those questions yet. What it has are the questions themselves. And sometimes that is where the most important discoveries begin. The next time someone tells you that death is simply the end, that the lights go out and nothing remains, you might want to ask them whether they have read the data. Because the data, published in peer-reviewed journals by researchers at the University of Michigan, at Stony Brook University, in The Lancet, in the Proceedings of the National Academy of Sciences, that data does not say the lights go out. It says something else entirely. It says that in the final moments, something in us turns on.